Here in this video, we are now going to learn about the advanced data modeling. You have already seen how the data model such as entity relationship model mostly and how to create it, what are the basic terminologies associated with it. But we are going to explore some advanced concept and with a relation to the entity relationship data modeling in this chapter. Here, our discussion in this chapter is basically divided into three parts to reflect the chapter coverage. So, the first part of discussion covers the extended entity relationship model, which is an extension or advanced entity relationship model. Second part of discussion covers the importance of proper primary key selection. And the third part of discussion covers four spatial design cases. These are the basics that we are going to cover today. So the objectives you can see all of them in the second slides. So let's start with our extended entity relationship model. So entity extended entity relationship model is a final output of adding more semantic constructs or advanced concepts to original entity relationship model. So to learn about the EERM, that is the extended entity relationship model, we need to learn some terminologies such as supertypes, entity supertypes, and subtypes. Here, entity supertype is a generic entity type that is related to one or more entity subtypes, where the entity supertype contains the common characteristics and the entity subtypes contain the unique characteristics of each entity subtype. The reason for using supertypes is to minimize the number of nulls, invalid values, and to minimize the likelihood of redundant or duplicate relationships. We just want to remove or reduce the duplications. Here to understand the entity subtype, one example I have included. So here see a pilot. Pilot, what is a pilot? It's a kind of an employee entity. So pilot is a subtype of employee entity, and employee is a parent entity or the supertype entity of the subtype pilot. So you got an idea about the supertype and the subtype entity. Now here comes the specialization hierarchy. So specialization hierarchy is in between the entity supertypes and subtypes, and both all of the supertype subtypes are organized in a specialization hierarchy. So what is that specialization hierarchy? We are going to see this or explore this in the next slide through a picture. So see here, the figure 5.2 is depicting the specialization hierarchy in between the employee entity, dependent entity, and the different types of employees such as pilot, mechanic, and accountant. So see, let's first explore what is a specialization hierarchy. Specialization hierarchy actually depicts the arrangement of higher level entity supertypes, that is the parent entity. So here in this case, the employee will be the parent entity or the supertype, and the arrangement between the higher level and entity supertypes and the low level entity subtypes, that are the child entities. For this case, we have pilot, mechanic, accountant. So this is the specialization hierarchy, and in this picture or figure, it shows the specialization hierarchy formed by the employee supertype entity and three entity subtypes, that are the pilot, mechanic, and accountant. So this is all together can be called as a specialization hierarchy. Here in this picture, it reflects the 1:1 relationship in between the employee and the subtypes, each of its subtypes. So for example, pilot subtype occurrence is related to one instance of employee supertype, and a mechanic subtype occurrence is related to one occurrence of employee supertype. Likewise, the same case goes on for accountant subtype as well. So, seen as specialization hierarchy, besides this supertype subtype, you can see some of the new terms: shared attribute, disjoint, overlapping, constraint, and some other like subtype discriminator. So we are going to cover all those concepts further in the later slides. So here comes, if we are learning about the specialization hierarchy, we should be familiar to the concept of inheritance. So if you have taken the programming courses or you know any of the programming, you must be sure that how inheritance is important for defining a structure. So inheritance enables an entity subtype to inherit the properties from a supertype entity. Okay. So let's see this through an example here. Mm, Here see we have the person entity. From the person entity there are two entities derived, or two entities, employee and student, are inheriting the properties of the person, and then two entities, administrator, professor, inheriting the property of employee, and graduate, undergrad, are inheriting the property of the student. This is how the inheritance can be applied to a specialization hierarchy. So again, I need to elaborate the overlapping subtypes. We have already learned the supertype subtypes. So if we consider only this portion, so overlapping subtypes, the employee and student, contain the non-unique subsets of supertype entity person. Okay, so they are inheriting um, the property of the person supertype entity, but they may contain the non-unique subsets of the person entity, supertype entity. And overlapping subtypes, administrator and professor, they may contain non-unique subsets of the supertype entity set, employee. And same thing goes on for the graduate and undergrad also. So non-overlapping subtypes, graduate and the undergrad, contain unique subtypes of the supertype entity set, student. And this is called disjoint constant. So what is this? If you see, the person is connected to employee through a connection here, oval shape. Okay, so person P is employee, P is EMP, and P is that is student. So here actually it forms a overlapping subtype relationship. So that's why I told that overlapping the employee and the student may contain some non-unique or overlapping characteristics from the person. That's why it's overlapped. And the same thing also can be applied to this case, employee with administrator, professor. But for the case of student, graduate, and undergrad, there is a D sign which implies disjoint constraint. That means the non-overlapping subtypes grad and undergrad contain the unique subsets of supertype student. So whatever characteristics graduate or undergrad will have, they are unique. They are not overlapped. That's what I'm trying to explain. Next comes the subtype discriminator. Let me show you that. So where is that? Yes, here. So a subtype discriminator is the attribute in the supertype entity that is used to determine to which entity subtype the supertype occurrence is related. So For any given supertype occurrence, the value of subtype discriminator will determine which subtype of the supertype occurrence is related to. This means what in this example, an employee supertype may include C1 property or attribute EMP type. It may include EMP type value as P to indicate the professor subtype, or let's say here in this case P indicates the EMP type, P indicates the pilot subtype, M indicates mechanic, and A indicates accountant. And here the subtype discriminator, that is same as equal to the attribute of employee, is presenting or pointing to as a subtype discriminator. Next, after subtype discriminator, we have disjoint and overlapping constraints. I just told you about some of the disjoint types and overlapping subtypes in this picture with the O and the D signification. So let's see what are these. So disjoint subtypes are also known as, let's look at that using our picture, it will be easier. So the disjoint subtypes, also known as non-overlapping subtypes, are subtypes that contain unique subset of the supertype entity set. So here this is the case, the right hand side from student, graduate and undergrad. So if we will move to this picture here in this figure 5.2, so here an employee supertype who is a pilot subtype can appear only in the pilot subtype, not any of the other subtype, that is mechanic and accountant. So in an ERD or entity relationship diagram, such disjoint subtypes are indicated by the letter D inside the category shape. Okay. Overlapping subtypes, to show you that one. Okay, let me try. So, okay, let's take this example here. So overlapping subtypes are subtypes that contain non-unique subsets of the supertype entity set. That means what? Each entity instance of the supertype may appear in more than one subtype. So for example, in this case, or let's take an university environment. So a person may be an employee or student, both. Okay. But in turn, an employee may be a professor as well as an administrator, because an employee may also be a student. Student and employee are overlapping subtypes of the supertype person. That's why you have this O sign here. Just as professor and administrator are overlapping subtypes of supertype employee. So I think you got some idea about the disjoint subtypes and the overlapping subtypes. Next, we have specialization and generalization. So specialization is a top-down process and generalization is a bottom-up process. Let's take this example from person, faculty and student at the right. So in the top-down process or specialization process, it identifies the lower level entities, okay, more specific entity subtypes from a higher level entity supertype. That is, faculty and student are being identified from the higher level supertype entity person. And it is based on the grouping of unique characteristics and relationships of the subtypes. Just the reverse of that is generalization, that is the bottom up process. So in order to establish this generalization, you should have the bottom level entities, and it's based on grouping the common characteristics and relationships of the subtypes. You are going to identify the higher level person entity generic supertype from the lower level subtypes. Next concept is about entity clustering. So entity cluster is a virtual entity type which is used to represent the multiple entities and relationships in the entity relationship diagram. An entity cluster is formed by combining multiple interrelated entities into a single abstract entity object. An entity cluster is considered virtual or abstract in the sense that it is not actually an entity in the final ERD, but rather a temporary entity used to represent multiple entities and relationships with the purpose of simplifying the ERD and thus enhancing the readability. Let me look out for the picture 5.6. Okay, where is that? Hmm. So in the picture 5.6, see there are, okay, yeah. So in the picture 5.6, there are two entity clusters, offering and location. These are two entity clusters with the shaded blue color. And offering groups the semester course class entities. Okay, it groups, yeah, actually they are not shown, but you may consider like this. It groups the semester course and the class entities, and the location may group the room and building entity details. So here one entity comprises of some collection of other entities as well, both of them of offering and location. That's your entity clustering. The next we have entity integrity or selecting the primary keys. So what is this about? You have already know what is a primary um, keys, right? So primary key characteristics rational. What is this about? The primary key must uniquely identify each entity instance, and it must be able to guarantee unique values, and it shouldn't contain null values. And the primary key should not have the embedded semantic meaning. An attribute with embedded semantic meaning is probably better used as a descriptive characteristic of the entity rather than as an identifier. So, in other words, let's say a student ID of 650973. You should always prefer this over the student's name, correct, as a primary key identifier. So it should be always numeric and unique. Next comes the natural keys and primary keys. So natural key is something, it is a real world identifier used to uniquely identify the real world objects. Let's come to some of the guidelines of the primary key. So these are the main characteristics of the primary key. So non-intelligent means what? It shouldn't have any embedded semantic meaning. The example that I just told you about the student ID, that always numeric values we should consider in place of the name of the student, as the name, let's say last name or first name, it may have duplications, or two similar students may have similar names as well, or similar last names or first name. And no change over time. That means if an attribute has semantic meaning, it may be subject to update. So this is why names do not make good primary keys. So if you have Vicky Smith, a student name, as the primary key, what happens when she gets married? So if a primary key is subject to change, the foreign key values must be updated. So thus adding to the database workload. So furthermore, changing a primary key value means that you are basically changing the identity of the entity. So it should be a preferably a single attribute, should be numeric, and security compliant means selective primary key must not be composed of any attributes that might be considered a security risk or violation. So for example, using a SSN number as a primary key in the employee table is not a good idea. Okay, someone should won't be um, agreeing to or it's not safe to share their SSN publicly. Next is when to use composite primary keys. So to understand this, here is the example that we are going to see. So composite primary keys are particularly useful in two cases: as identifiers to composite entities, where each primary key combination is allowed only once in the many-to-many relationship; as identifiers of weak entities, where the weak entity has a strong identifying relationship with the parent entity. So to illustrate the first case that I just said, assume that you have a student entity set and a class entity set. So in addition, assume that those two sets are related to each other by many-to-many relationship via an enroll entity set in which each student or class combination may appear only once in the composite entity. So as shown in this picture, the composite primary key automatically provides the benefit of ensuring that there cannot be any duplicate values. That is, it ensures that same student cannot enroll more than one in the same class. Next comes surrogate primary keys. Now, what is this? So this is a special type of key which is called which is an artificial primary key that is used to uniquely identify each entity occurrence when there is no good natural key available, or when the natural primary key would include multiple attributes. So a surrogate primary key is also used if the natural primary key would be a long text variable. The reason of using this key is to ensure entity integrity, to simplify application development, and by making queries simpler. To ensure query efficiency, let's take an example. A query based on a simple numeric attribute is much faster than one based on 200-bit character string, correct? Okay. So, and to ensure that relationships between entities can be created more easily than would be the case with a composite primary key that may have to be used as a foreign key in a related entity. Okay. So there are some performance issues that we need to look at it while determining this type of keys. So let's take this example. Okay. So if you see in this picture here, this entity and data is used to keep track of the event, and these are the individual attributes and their values in the individual records. So the event entity here, this is the event entity, and event entity can be modeled with the attributes such as date, time start, time end, room, event name, and party of. Okay, let me show you this. So here, this is the event entity with all the attributes. So for this primary key can be, let's assume randomly. So date, time start, and the room. See, we have duplicate data. Okay. So looking at that, we can determine the primary key to be date, time start, and room. Or another one can be date, time end, and room as well. So here, these are the possibilities of the primary keys, and both of them are your composite keys. If we are forming keys using multiple attribute values, that is called composite keys. So let's take an example. Suppose one event may use resources such as tables, projectors, chairs, and the same resource may be used for many events. So for that case, we have to create another one divided entity which may be named as resource. Okay, and we may name it with, or we may have to gather the attribute values with the resource ID. All the resources, tables, projector, chairs would have the IDs, right? their ID, resource description, resource type, quantity, and price. Okay. So if we create that, then just think about it. The many-to-many relationship between the resource and the event. So one event can have multiple resources. Multiple resources can also be having a many-to-many relationship with the event as well. And it would be represented via one event source composite entity with the composite primary key as like this. Event source, another one third entity to be included, and it should have the some of the keys from the event entity and some of the attribute and the combination of primary keys from the resource entity as well. So this is the condition where to use surrogate primary key as the composite key, which is lengthy enough and it can create unnecessary ambiguity. So for implementing the one is to one relationship, there are certain criteria that we need to look at too. So foreign keys, while determining the foreign keys primary key, we should be most careful and place the primary key and the parent of the parent entity on the dependent entity as the foreign key. So while determining the primary key foreign key, you need to be careful about what are the attribute and what are their values. Are they unique or not in the primary key side? So and then there is a table given for entity ER relationship constants and what actions should be taken for each one of them. If one side is mandatory and the other side as well, and if both the sides are optional, what are we supposed to do for determining the primary key foreign key? And if both sides are mandatory also, for that case, what are you supposed to do? One example is shown here in between the department and employee entity, where there is one mandatory participation and one participation from employee, but there is an optional participation from the department side, and there is a one is to one relationship. So this is all about your advanced data modeling chapter.